Welcome to springlib.
This is the answer to Chapter 11, problem number 23 from the Smith Organic Chemistry textbook. And this problem says devise a synthesis of, I guess it would be butaldehyde from 2 carbon starting materials. And so we have an aldehyde, and we learned in this chapter that we can install an aldehyde by hydroboration oxidation of a terminal alkyne. So that's probably a strategy we're going to want to keep in mind. And we're told to use 2 carbon starting materials. And so we're going to need to make at least one, we're going to need to make 1 carbon-carbon bond here. And a way that we learned how to do that in this chapter would be to use an acetylide ion. And so that's where I will start. And so if we start with acetylene, we can deprotonate acetylene with a strong base, so sodium amide, for example. So NaH is going to get us the acetylide ion that we want. This acetylide ion can then react with ethyl bromide. Because again, remember 2 carbon starting materials here, and we only need 4 carbons total. So ethyl bromide, and the acetylide ion will do a nucleophilic attack and displace that bromine. And so now we have our 4 carbon chain, and we have our terminal alkyne. Okay, and so to get from this 4 carbon terminal alkyne to a 4 carbon aldehyde, all we have to do is make use of hydroboration oxidation. So R2BH followed by hydrogen peroxide and some base. And that is going to get us to our target product here. Okay. And so in order to accomplish this, we need to sort of think backwards and realize that we have an aldehyde as the major functional group in our product. Remember that we can install an aldehyde by hydroboration oxidation of a terminal alkyne. And then remember that we can get our terminal alkyne and link our two carbon subunits together by taking advantage of the reaction of an acetylide ion with ethyl bromide. And that's the answer to Chapter 11, problem number 23.